Hey everybody, it's Tom Cherryholmes with the FujiNet project, and I wanted to do a video that has been requested by more than a few users who are interested in hacking on the FujiNet firmware, but are not exactly sure where to start. So I will actually try to make one of these for at least the Linux and Windows operating systems here, and if I can get a Mac OS virtual machine working, I will try to do one for Mac OS as well. What we're going to do in this video is essentially set up the necessary development tool chains required so that you can hack on the FujiNet firmware and upload the resulting firmware to your FujiNet device. Even if you're not going to do any firmware development, you can still do these steps to make sure that you have the latest copy of the FujiNet firmware if you want to test out features before we actually roll a build. So, with that, let's get started. We have right here a Ubuntu installation, pretty much blank at this point. Nothing has been installed other than the bits and pieces needed for my virtual machine to operate properly. We need to start by installing some development packages. Now, since these commands need to happen with root commands, we go ahead and sudo out, enter in a password, and we find ourselves at the root prompt here. We need to install, make sure that build essential is installed. This will provide all the necessary software development baseline utilities that we need. We also need a copy of Git, and because PlatformIO is built on top of Python, we need a couple of Python libraries as well. We need Python 3 vin, which is the virtual environment package, and we need Python 3 distutils. Distutils is actually used to install various parts of the PlatformIO framework. We'll go ahead and install them. It'll only take a few moments. And once this is done, now we can turn our attention to installing VS.Code. We can go ahead and close this window. We'll open another one up in just a moment. And we'll start a web browser. Any web browser will do. By default, we are set up to search for Google here, but you need to go to the download page for Visual Studio Code. You can see there's one right here, codevisualstudio.com/download. And you'll see that you're presented with 3 potential platforms that you can download. Download the one appropriate for your platform. Since we're on Linux, we'll go ahead and use the Debian package here because we're running under a Debian or Ubuntu-based operating system. And in a few moments, it will ask us how we want to open this. Now, if you've installed your Ubuntu installation by default, it will take and have software installation helpers in there for you. If you don't, then you need to use the appropriate methods manually to install this package. With this in place, in a few moments, we'll take and have the software package come up. Hopefully. If not, I guess I just need to, oh, there we go. It just took a moment. All we have to do is click install. Enter in our password. And within a few moments, it will take and install VS Code for us. Almost done. So there we go. We're done. We can close this window for us now. And we can actually take, and we don't need to do that right now. Thank you very much. Close tabs and quit. Yes, absolutely. And at this point, if we look under development, we find a copy of Visual Studio Code. And I mean, I can, for example, go ahead and take and add that to the panel. And perhaps go ahead and throw it onto the desktop as well. Sure, why not? Boom. So with that in place, we'll see that it actually did put a Visual Studio Code icon way up here in the teeny tiny little panel. If we take and go into it, we see our VS Code window come up with the options to pick, to customize setups and everything. If you want to deal with that, go right ahead. You really don't need to do it. We'll just go ahead and pull all this out of the way for a moment. And the first place we need to go is we need to install the PlatformIO IDE extension, which will also install PlatformIO for us. We type in PlatformIO, and we see the very first one right here is the PlatformIO IDE. We click Install, and it will automatically start installing it for us. At which point, you'll see a series of tasks start to show up as we install the various PlatformIO dependencies. Now, this will install the absolute minimum required for PlatformIO to function. As it needs other components, it will install them as it needs them. We go ahead, reload now, and PlatformIO, you will see now that there is a PlatformIO logo ready to go. And I believe that's supposed to be an ant head. I think so. Now that we're here, since we went ahead and installed Git, we can go ahead and we can actually clone a project that we want to deal with. The project that we want to clone is actually on GitHub, so we can literally take and enable the GitHub integration. If you don't have an account on GitHub, it's a good idea to get one. You get access to your own little place where you can put software code, etc. It's a good thing to have. We'll go ahead and authorize access. And I will put in my username and password for GitHub. Allow this site to open the VS Code link. We want this to happen, and yes, we want this to always happen for VS Code links. We choose application, and it helpfully goes ahead and gives us the URL handler for Visual Studio Code. Always use this for VS Code links. Open link, and it's, yes, fine. Click open. And since this is a new installation, I haven't initialized a keyring, so I need to go ahead and put in a password to create the keyring. No problem. Continue. And now we have access to all of the, by default, it will show me my most used repositories under my GitHub account. We need to go and pick something up in the FujiNet Wi-Fi. So FujiNet Wi-Fi, all one word, / FujiNet -PlatformIO. There it is. Boom. We now need to take and specify a repository location. And this is entirely up to you on how you want to deal with this. I typically take and create either in the home directory, or I create a folder called workspace. And then, yes, we would like to go ahead and open the cloned repository. And you'll see its directory tree over here on the left-hand side. We need to go ahead and set up a couple of things with regards to our FujiNet hardware. To do this, we'll go back into the PlatformIO section, and we will go into Devices. You'll see that there is currently not anything here that it can detect. That's okay, because we actually need to, while we're at it, sorry, I did this slightly out of sequence. We'll go to Platforms and install the requisite platform that we need. We go ahead and select Install Embedded Platform. Espresso32. Select, install the latest version, which as of this video is 3.2.0. We're making it a policy to always make sure that this firmware will build under the latest version of the platform. So be sure to pick the latest version that you can. PlatformIO and the VS.Code environment will try to take care of making sure that these things stay up to date. In a few moments, we'll see the platform installed. And we can then start looking for devices. Right now, it's not finding my FujiNet that I have connected, because in reality, I'm running inside of a virtual machine. But let me see if I can get it to recognize it by unplugging and plugging back in with my VirtualBox window selected. Let's see. We press refresh. Let's see if it came up. Nope, not yet. Let me see if I can get this to fiddle here. I will pause the video ever so slightly. Mostly involves just trying to unselect, reselect, and try to get your board to show up here in the list. One moment, please. After selecting in my VirtualBox Devices menu the USB to serial bridge, it was able to see the device. We can see right here that it is dev TTY USB 0. We can go ahead and click for a copy port name to clipboard. This will be important in just a few moments. Once we have this, and we know that this is completely set up, we then go back to the file view and we open up the platform sample INI file. This is an example copy of the platformio.ini file and needs to be modified to fit our environment. By default, this is set up for Windows. We're running under Linux here, and it just so happens that the serial port that we're looking for is the one that's already in here by default. So it was just as easy as me changing out and commenting out the other port. So with these two set up right here in common, we can then make sure all of the production FujiNet firmware uses this particular hardware definition. This is for an ESP32 with 16 megabytes of flash and 8 megabytes of PSRAM. Some of these other hardware definitions are for older versions of the FujiNet and really aren't really needed. They can clutter up your task list. So if you're just using the standard production hardware, then all you really need to do is make sure that this one is selected and that this one is available. With that, we'll go ahead, File, Save As, being sure to click Save As and calling it PlatformIO.ini. Once this is in place, we actually need to exit for just a moment. And we need to restart our environment. This is so that PlatformIO and VS Code will pick up the changes and adjust our environment accordingly. You'll now see that because we've done this, within a few moments after PlatformIO initializes, you'll start to see tasks such as the rebuilding of the IntelliSense index, and, more importantly, loading of tasks. This will take a few moments. Now that both tasks have disappeared, we are now ready to use our development environment. If we click back on to the PlatformIO icon again, we will now see that there's a new pane up here called Project Tasks. We can resize this so that we have better access to it. And we'll see some things that are very useful during our development workflow. Of course, there is build, which does the obvious, and upload, which also takes and uploads the resulting code to the device. And you'll find that there are certain tasks that are combined because you'll find yourself using them over and over, such as upload and monitor. Upload also does the build step. In addition, there is also upload file system image, so that you can upload if there are any changes to the data directory, which ultimately gets uploaded to the SPIFS file system on the ESP32. We'll go ahead and try a build here to make sure that everything works as expected. The first time the build is attempted, it will take and build the majority of the ESP IDF framework, but it also quietly installs certain things in the background, such as the CMake utility and various bits and pieces of the toolchain, in order for the build to be able to complete successfully. The first time you do your build, expect a build time of approximately anywhere from 5 to 10 minutes. The very last part of the compilation step is the linking of the firmware elf, and this will let you know when the compilation is nearing completion. You will see here a set of statistics, most importantly how much RAM is used of the low memory area, of which there is approximately 320 kilobytes of space, and of the flash memory space, of which there is approximately 6.2 megabytes actually actively available at present with the current partition structure that we have. And yes, this took long enough that now my screensaver has enabled. We'll come back. And here we go. We know this compilation took approximately 316 seconds, and we know that it's successful, so we know the build environment is working as expected. You'll find here the most common thing that we will do as you start working on the firmware is you will make a code change, most notably usually somewhere in the library directory. And once you're done, you can come back to the tasks, do an upload and monitor to see your results. You'll see here that the upload and monitor step has installed an additional utility for making the SPIFS file system. We can see right here a common error that happens especially when setting up. We see a permission denied for dev tty USB 0. And undoubtedly this may happen to you too. The fix for it is very simple. We just go ahead and go into our settings, go into our users, and change manage groups here, and we just need to put our user in the dialog group. go ahead and authenticate so that it can make the changes. And once this is done, we can close this, and we just need to log back out and log back in again. No big deal. Once we've logged back in, we should be able to upload to the device just fine. We come back into Visual Studio Code, and it will pick right back up where we left off. A few moments later, you'll see the PlatformIO window reappear. And within a few moments, once it rebuilds the various bits of internal files, we will see our task list reappear. All good. At this point, we can then take and upload and monitor. Since we've already done a complete build, this will be considerably shorter than if we had just attempted a build from scratch. You can see it here connecting to the device and writing out the flash data. This only takes a few moments. Once we've hard reset, the FujiNet will go into monitor mode, and you can start to see the debugging information coming back from the FujiNet. Since my FujiNet is already configured, you see it has already gotten an IP address, attempted to connect to my network, and everything has already resynchronized the time. We can then test our result. Let's go ahead and enable my Atari capture device and do a cold start. You will see right here that we've booted into the configuration program. And it is very useful to have this VS Code window open because right here we have a debugging window that we can see all of the SIO traffic. And you can see that it works. You can see all of the different things that come across. Very handy for development. Apologies for the mowers outside. We'll go ahead and mount that. And we'll see everything come into place here. Boom. So there we go. This gives us everything we need in order to do firmware development here. And in fact, really, the only other thing that we really would want is if you wanted to work on the Atari side of things. And that's easy enough, too. We'll go ahead and put the Atari display out of the way here. And we will go ahead and install a copy of CC65. And again, this is pretty easy. Oop, and I realized I'm clicking on, my bad, I'm clicking on my OBS window. Apologies. So getting CC65 is simple enough. We really just need to get a copy of CC65 from GitHub and build it, put it into place. For that, we just need to go ahead and clone a copy of CC65. And all we really need to do is git clone github.com/cc65/cc65.git. This will get us what we need. No pun intended. And yes, since I put HTTP, it redirected to HTTPS. You can see that it's created a CC65 directory for us. And all we really need to do now, since we have all of the development tools previously installed, we can simply run the make file. And I put a -J on here to spawn as many jobs as possible to get this compiled done as quickly as possible. Ostensibly, you want to use a value for J that is +1 more than the number of processor cores you have available. This will take a few moments to complete. Expect anywhere from, again, 5 to 10 minutes, depending on the computer. With the compile finished, we can then take and install CC65 into its final place using sudo and it says right here, prefix must be set. Easy enough. All we have to do here is go ahead, go into interactive for just a moment, go back into where we found CC65 and set prefix. And I will put prefix to USR local. We can put it as USR local CC65, for example. And now that CC65 is installed, we really should make one more adjustment to our user profile. We do this by going ahead and modifying our profile. Control D to get back to our user. And then using whichever text editor you wish to use, we can go ahead and modify, for example, either our bash RC or our profile. Do not have Emacs. Do I have VI? Let's see. And for this, we just want to go ahead, CC65 home, USR local CC65. Right quit, dash profile, and let's go ahead and log out and log back in to see if the environment variables will stick. With this in place, we can, for example, go ahead and use VS.Code again if we wish to close out our project for dealing with, let's see, let's go ahead and close this project completely. Boom. Boom. Ahead and close folder. Boink. and we'll take and open up a new repository. This time we will clone from GitHub again. And since we already have our credentials in, it's just taking us straight to there. FujiNet Wi-Fi, FujiNet config. This is the configuration program that is embedded onto each and every FujiNet. We'll go ahead and put it here too. And yes, we would like to open the closed repository. We'll see right here that we have our code that we can take and modify it. All good. We can subsequently go ahead and go out into the terminal, for example, new terminal, and we can make the resulting code. Let's make sure that CC65 home is set, and it is not. USR local CC65, and we can make the result. And right there, almost immediately, we wind up with our config program ready to go. And that's how we build the Atari side of it as well. I will take and go into more detail on this in a future video. But hopefully this kind of gets everybody started with the process of getting the development environment set up so that we all can work on FujiNet firmware together. And with that, I leave with my usual ending of being sure to always have fun.